Double and triple bonds. All the elements are defined by the number of protons they have, their atomic number. When neutral, they have an equal number of electrons. The number of neutrons can vary and can be found by looking up the atomic mass and subtracting the atomic number. For now, the atomic number is critical. Here are the two elements we've discussed so far, with their atomic numbers indicated. Hydrogen and helium make up period 1, the first row of the periodic table. Here are all the elements with just their atomic numbers given. Each row in the periodic table is called a period. This course will mostly work with the first 3 periods, the first 3 rows. This shows the first 2 periods of the periodic table. We have hydrogen, lithium, and beryllium, helium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Every period or row of the periodic table has an inert element in its rightmost column. The inert element in period 1 is helium. It has 2 electrons. The inert element in period 2 is neon. It has 10 electrons. All inert elements are stable. They do not take part in any chemical reactions. We saw that 2 hydrogen atoms combined to form H2, so that each atom could share 2 electrons, like helium's number of electrons. H2 is an example of a diatomic molecule, a molecule made up of 2 atoms. As in all molecules, the atoms are held together by covalent bonds. In nature, hydrogen atoms are never alone. Hydrogen gas is H2. In period 2, elements share electrons to get to 10 electrons, like the number of electrons in neon. For elements near neon on the periodic table, one solution is to form diatomic molecules like H2. Which are the 3 elements in period 2 closest to neon? In nature, nitrogen, oxygen, and fluorine are not found as lone atoms. One way they are found is as these diatomic molecules, N2, O2, and F2. Each pair of like atoms forms one or more covalent bonds, which allows them to share electrons, so that each atom effectively has 10 electrons. N2, O2, and F2 are gases. Energy is released when the bond forms, and energy is necessary to break that bond. Oxygen must form 2 covalent bonds to be stable. It can do that by bonding with 2 other atoms. However, when it bonds with just one other atom, as it does to form O2, it forms 2 covalent bonds between them as shown here. This is called a double bond. Double bonds are shorter and stronger than single bonds. Nitrogen must form 3 covalent bonds to be stable. It can do that by bonding with 3 other atoms. However, when it bonds with just one other atom, as it does to form N2, it forms 3 covalent bonds between them. This is called a triple bond. Triple bonds are shorter and stronger than single or double bonds.